All right, welcome to Doozer Shop. This is going to be a video I'm going to try to record about reforming capacitors when you leave them sit for a long time in electronic devices like variable frequency drives and maybe stereos and different things, but it's going to be kind of free form. Let's grab the camera and get into it. And I know you like to kind of see my shop, so so let's pick out our device here. Got two VFDs, that one and that one, and I got the test rig here, so let's move the saw. Forget which one is better. You know what, I think this one you gotta play with the panel. This is an Automation Direct one. Alright. You know what? I gotta get around. Alright. Alright. Yeah, let's get this up. It's what it is here. Here you go. Durapulse. We love it. Alright. I got on the welding bench. Philippe's. Alright. Let's see. Carefully, Doozer. Oh, it's got these little. Hold on. Let me show you. Alright, so I had to pick the hard one, right? Let me get a screwdriver. Okay, that's all I needed was a flat. Alright. On top hinges. I don't want to break it. Shake, shake, shake. Shake the top off. Shake the top off. Alright, I'll pick you guys back up. So there's the works. There's the top. Oh, this is important. So this is the brain pad. And it's got like a little pluggeration in the backetation. And I think it plugs there. So alright, so that's set there, and so we got power 1, 2, 3. I don't remember if you have to jump something. I don't think so. I think on the Hitachi you have to jump 2 and 3. Anyways, this is an Automation Direct 1. Alright, so we come back over to the cubby hole and we grab this guy. This is a variable transformer, also known as a variac. Don't know why it's called that. Very active? Don't know. Alright, so. And unwind it. It's going to be a longer video, but you know what? Haven't done one in a while. Yes, I can plug it in. Yeah, alright, there's crap everywhere, but whatever. Alright, and that's just a 2-wire to 3-wire adapter, or 3 to 2, and whatever. Okay, now old school light bulbery. So what I'm going to do is to limit the current I'm putting the light bulb in series with the works here. Okay, so let me just, all right, put that there. So input power, I'm going to plug into the Variac is this cord. It's very dirty. This is off an old Oster can opener. And the light bulb is in series. So the one leg passes through to the black, and then the other leg goes through the light socket, and it's the white. So if you know what a series circuit is, you know, there you go. All right, so put the Let me put you over here. All right. Yeah, I'm kind of setting you on. Now, so I'm putting the wire under terminal number 1. Yeah, tighten it up very lightly. Putting the second wire under terminal 2. Okay. Now, alright, we're gonna just, alright, so pick you back up. So what we have here is the power cord. One line goes to black and one line goes to the light bulb. I think that's 60 or 100 watts, I forget, it might be 60. And then the other one goes to the input. So what we did is we connected input power to 2 phases. I'm sorry. We connected input power to 1 phase or 2 legs, because this is meant for single or 3-phase input. Now phases exist between the legs, so these legs are technically not phases. Whatever. Okay. All right, I'll put the light bulb there. I'm just trying not to drop anything. Oh, jeez, don't drop anything, Doozer. And we're just going to plug ration the thing in the... Okay. All right. So the light bulb is plugged in, series. That's a better shot. Alright, anyways. So if you know what a series circuit is, my gosh, you guys, if you're watching this channel, you know what a series circuit is. Okay. Inside there's capacitors, and what reforming capacitors is all about. And I'm going to try to be simple about it, and I don't know exactly, I'm not an electronic genius, but the capacitors take a set, the electrolyte, you know, there's 2 plates and it's wound in a spiral core with insulators and separators, and there's a conductive like battery acid in there. And I don't know if it crystallizes or what it does. But this is supposed to slowly apply voltage while limiting the current. That's what the light bulb's about, and this is what the variable transformer is about, starting off slow. So my buddy Bruce in North Carolina, he's quite the electronics guy. He's got a gigantic electronics lab hidden inside of a barn. You wouldn't even know it's there, but it is the most fabulous, up-to-date laboratory I've ever seen for electronics. But anyways, he could probably correct me in the comments if I say anything wrong. So anyways, this variable transformer, or Variac, it goes from 0 volts up past 120, and it'll actually go higher than the line. It'll go 130, 140. So what I'm going to do is I'm going to turn it on. It's on 0, right? See, this is on 0. I think that's on. Hope it's on. And see, I got nothing. And this is supposed to be 230, 240 volts AC. We're not going to get anywhere near that. We might get a little over 120. So what I'm going to do, here, let me, maybe I'm going to shut the light off. Alright, we're going to shut the light off. We're going to start, we're going to watch the lamp, we're going to watch the light bulb, I'm going to turn this up. We're going to do this real slow over the course of about a minute. And we're hopefully both in frame. There's 10 volts. We're doing this kind of slow. Ooh, I heard some heat happening. Heard a little teak. $30 volts. I forget when this lights up. 40. So you're supposed to do it slow. I did this a couple months ago, so but I'm showing you as if 50 volts. 70. 80, 90, 100. This should be doing something. Oh! It just, the fan came on. Under voltage. Okay, that makes sense. I'm at like almost 110. Let's watch. Oh, the light bulb's glowing. Okay. Watch the light bulb. So I'm going to keep going. 120. 130. Okay, 140 volts. And the light bulb has seemed to go out. So the light bulb being on was charging the capacitors, and now, like, I can turn it back down, and it's out, right? So, oh, see how it got bright? So that's the capacitors charging. Let me go down to 110, and then I'll go up to 140, kind of quick. And see how the light bulb gets bright? That's the capacitors charging. So when I move it back down, the capacitors are discharging a little bit because the voltage is getting lower. You can see that it's lit again. And as I go up and the capacitors get charged, the lamp starts to go off. You can barely see that there, it just turned off now. So this works out pretty good at 140 volts. And this lamp is a what the heck is it? I don't even know if it's a 60 or 100. I think it's probably I don't know what it is. It doesn't matter. But anyways, under voltage, and it's flashing stop and da-da-da-da. But you can hear the fan and you can hear everything, and that's how you do it. So let's kill it. Let's kill it. And you can see it takes a second after I kill it for the capacitors to continue to run the fan. Now it's completely dead. So what I'm going to do is I'm going to flip this thing on really quick. You know, I'm not going to vary the voltage at 140 volts input. And what's going to happen is, as you might imagine, that lamp is going to flash full bright and then go out as the capacitors charge. At least it did last time I played with this. So here we go. Real quick, watch the lamp. Really bright and then back to almost nothing. And it took a second, but there you go. Then you can hear the fan. But that's the deal with capacitors. And there goes the fan. So capacitors are, when they're charging, man, they're hungry because they want to charge instantaneously fast as physically possible, I guess. So that's why you see the current surge through the filament. Do it again. Da-da-da-da. And then, come on. Please. Right. I mean, I'll turn it off so we can talk. So all this is a light bulb in series. To the filament limits the current. Now, if this didn't make sense, this is not an LED light bulb. This is a tungsten filament light bulb, old school light bulb. It's not going to work with an LED light bulb. It needs to be a filament light bulb. Okay, those in electronics, it's basically a heater. It's a resistor. LEDs have electronics and da-di-da-da-di-da-da, and it's not a thing. So, and this is not even a big variac. I don't know what it is. Maybe it's 300 watts or 500 watts, something like that. But that's as difficult as it is. And it's surprising that this thing works at 140 volts. Actually, it works just over 110 volts. Because it's designed for, 230, 240 volts, three-phase. But it does work. So anyhow, I just wanted to make this quick video, and I showed you all my going and getting the screwdrivers and taking it apart and hooking it up, because I wanted to show everybody that this is not that hard to do. And I just got, wire nuts and just, little scrap wires hooking everything up. But you need a variac. I guess you don't need one if you had a light bulb in series and just plugged it in across the line. It might work, but if there are official technical documentation especially from VFD manufacturers, how to reform the capacitors if they're sitting for more than 5 years or 3 years. This thing was sitting for 10 years. I bought this 10 years ago, planning on using it. I'm just getting around to it now. Actually, the documentation, I don't know if I think it came from Automation Direct, but it was under their Hitachi stuff documentation. But it could be under the Durapulse. I don't remember. But Automation Direct, great website, great people there in Atlanta, Georgia. And I've done this with the other VFD in there with the Hitachi, and it works the same. The only difference, I think, the Hitachi, you jump L2 and L3 if you're running it on single phase with the jumper, and then you feed L1 and L2/3. But other than that, it's the same thing. But they recommend in the procedure to increase the voltage a little every second. So if you span that whole thing over a minute, I kind of did it fast. I mean, it's not super technical. You just don't want to zap those caps. Now, I think this is a 10 horse VFD. When they get big like this, 10 horse, the caps get really big. So the ideal thing is to leave these turned on all the time. I mean, don't leave the motor running all the time. The fan will shut off after, I think, 20 seconds. The fan does shut itself off if it senses it's not being used, so that's cool. But leave this thing running all the time. Other VFDs I've got over, on that mill and on that grinder in the corner, I leave them on pretty much all the time. Oh, and there's another. That way the caps stay charged and there's no inrush. It's not that important because that's a 1 horse and that one's like a 3 horse or something. But when they get big like this, leave them on all the time. Or, I mean, you don't have to, but boy, that sure works nice to put the light bulb in series when you turn the power on, and then it'll flash the power will come on, and then just wire a switch to short across the light, the lamp right there. So it takes it out of the circuit, and it's just direct power. Don't forget to open the switch when you turn it back on, so the light is active, the lamp is active. I guess that's it. I had nothing more to say about this other than it's a quite a technical subject if you go to read about it, but in reality it's just a light bulb, a variac, and some wires, and just turn the knob up really slow over the course of, I guess, a minute is the takeaway, the summation. Hope you enjoyed this video. I hope it helps you guys. If you buy a VFD, especially anything more like 5 horse or more, I would definitely do this. If you bought it and you don't know how long it was in storage, do this reforming the capacitor thing. In lieu of a variac, could you use a light dimmer, like for a plug outlet wall switch light dimmer? I don't know. Maybe Bruce could comment. Light dimmers, lamp dimmers are a triac inside with the variable resistor. Triacs are kind of neat because they turn on at 0 voltage cross. So when the sine wave of AC goes up and down, positive, negative, a triac will turn on always at 0. It'll never turn on the high point. Sometimes that's useful in electronics, but will a triac work? They're not very linear. They're not very linear. I think it's better than nothing to use a lamp dimmer, but an actual transformer type variac is really what you want. And like I said, that's either an 80 or 100 watt light bulb. I don't remember which. Sorry. I don't think either one would be bad. I think either one would work. All right. Leave some comments. I hope this helps you guys with reforming capacitors, especially in variable frequency drives. Maybe you need to do this in stereos, amplifiers too. I don't know, but I guess it couldn't hurt. Until next time, Doozer Shop.